Have you ever stopped to think about what's really powering the biggest apps on your phone? Well, there's this unseen engine working away behind the scenes, and it's basically become the backbone of the modern web. Today, we're going to pull back the curtain on this incredible piece of software, Node.js. Yep, that's right. Whether you're binge-watching your favorite show, calling a car, or just scrolling through your professional network, you are using Node.js. It's the silent workhorse that's juggling massive amounts of traffic and data for the services we rely on every single day. And that really is the million-dollar question, isn't it? How on earth does it handle millions of people all at once without just falling over? Well, in this explainer, we're going to uncover the 3 core secrets that make Node.js so unbelievably fast and powerful. All right, first up, let's talk about what happens when things go wrong. Because, let's be real, in the world of software, things always go wrong. This is where Node.js has a really clever system of warning lights. It's just a fact of life. Networks drop, users type in weird stuff, files disappear, and any system that can't handle those little hiccups is a system that's just going to frustrate everybody. So the goal isn't to build something that never breaks. That's impossible. It's to build something that doesn't completely shatter the moment it does. To do this, Node.js uses something called an exception. You can think of it as a formal signal, a red flag that pops up and says, hey, something unexpected just happened here. It's exactly like the check engine light in your car. It doesn't bring the car to a screeching halt, but it lets the system know there's a problem that needs attention, so the software can handle it intelligently instead of just crashing and burning. And this right here, this captures the entire philosophy. It's a total shift in mindset. Instead of chasing some impossible idea of perfection, great software is all about building systems that can anticipate, catch, and then manage those errors with grace. This makes sure your experience as a user is as smooth as possible, even if things are a little chaotic behind the scenes. So, how does this actually work? Well, Node has to think about when an error happens. For synchronous errors, problems that happen immediately, in sequence, it uses what's called a try/catch block. It basically tells the code, okay, try to do this risky thing, and if it fails, catch the error before it makes a mess. But for asynchronous errors, the ones that might happen later, after a network delay or something, it uses a different method to stay ready and catch that error whenever it finally shows up. Okay, let's get to our second secret, because this is where things get really interesting. If Node.js is an engine, it's a super unique one. It's an absolute master of multitasking, just maybe not in the way you'd expect. I mean, this is the classic problem for any big website or app. Just imagine thousands of people trying to order from one restaurant at the same time. It would be total chaos, right? Now, the obvious solution would be to hire more and more chefs. But Node.js has a much smarter, way more efficient way of doing things. The answer is something called the event loop. And the best way to picture it is this. Instead of having 100 slow cashiers, imagine having just one who moves at lightning speed. That's the event loop. It's the heart of Node.js, a single coordinator that makes sure absolutely no time is ever wasted. So here's the process. First, our super fast cashier takes an order. If it's quick, like pouring a soda, they do it right then and there. But if it's a slow task, like cooking a big meal, they don't just stand there and wait. No way. They hand that order off to the kitchen staff and immediately turn to the next customer in line. They're constantly checking back with the kitchen, and the second a meal is ready, they grab it and serve it. That's the whole idea behind what's called nonblocking I/O. And this leads us to the single most important role in the entire system. You have to keep that cashier moving. If you give the cashier a task that makes them stop and think for a long time, the whole line just grinds to a halt. In the Node.js world, we call this blocking the event loop, and it is the absolute cardinal sin of performance. And you can see the difference right here. On one side, you have the bad way, blocking. This is like asking your cashier to stop taking orders and count every single grain of rice in a 50-pound bag. Meanwhile, a huge line of angry customers is forming. But the good way, the smart way, is offloading. The cashier just hands that bag of rice to the kitchen staff, and in Node's world, these are called worker threads, and then they just keep on serving customers. Efficiency is all about delegation. Okay, this brings us to our third and final secret, which is all about how Node.js deals with the absolute flood of data that defines our world today, everything from massive video files to live social media feeds. Seriously, think about this for a second. If you had to download an entire 50-gigabyte movie file before you could even start watching, you'd never press play. So services like Netflix have to find a way to send you that movie piece by piece, which requires a totally different way of thinking about data. The solution is this brilliant concept called streams. So instead of trying to load a gigantic file into your computer's memory all at once, which would probably crash it, Node.js uses these digital pipes. Data flows through them in small, manageable chunks. It's way more efficient and keeps everything running smoothly. Let's walk through a quick example. So, a readable stream opens a huge file and starts sending out little pieces. As each piece flows through the pipe, a transform stream can grab it and do something to it, like compress it to save space. And finally, a writable stream catches those compressed pieces and saves them to a brand new file. The amazing part is, the entire massive file gets processed, but the whole thing is never sitting in memory all at once. And once you know what to look for, you'll see this technology is literally everywhere. Every video you watch, every big file you upload to the cloud, every podcast you listen to, it's all powered by streams. It's the magic that makes handling these enormous amounts of data feel totally instant and seamless. So there you have it, the 3 secrets behind the power of Node.js. And you see, it's not about having more raw power. It's all about being smarter. It prepares for failure with its check engine lights, it manages thousands of tasks with its incredible one-person cashier, and it tames massive floods of information with its data pipes. These core principles have made Node.js an absolute dominant force on the web. But it also leaves us with a pretty big question. As we move into a future with AI, virtual reality, and just unimaginable amounts of data, what new kind of engine are we going to need for the internet of tomorrow?